Okay, so here we have a calculus problem of the day. This one is going to be using integration. Probably getting a little bit familiar with integration and maybe familiar enough now to know that it is not always as simple as taking derivatives. So with derivatives, usually you have a pretty easy formula to use. Maybe a combination of formulas, maybe you're using the chain rule along with the quotient rule or the product rule or whatever it is. But typically, the derivatives follow a pretty easy step-by-step process, and you can get proficient at those pretty quickly. Integrals, on the other hand, take a little bit more intuition, I guess, and can be a little bit tricky. So, um, we have this one. Now this integral is in the section on U substitution. And so U substitution can be a little bit tricky at first. So what we're going to do is we're going to figure out um, how to do a substitution to make this integral very easy. And once we do the substitution, it is very easy. So typically a good idea. So we need to find something to let U equal. So U equals something. Now, how do you know what it equals? Well, U equals X is never a good option because that doesn't really do anything. All that does is change the letter, but it doesn't change the function at all. Um, so so we have the X, we have square root of X squared plus 3. That's a little bit complicated to take the integral of. But you can also look at this X squared plus 3. Now, typically, uh, I would say that to find the U, you need to find the most high level, I guess, or complex function that is not a composite. So if you look at this square root of X squared plus 3, that's kind of a composite function. Um, you got the X squared plus 3, you got the square root. Those are two different functions that are composed together. Um, so let's try X squared plus 3. Now, like I said, U equals X is never the right answer because that doesn't help. And so sometimes you may have to try something, and see if it works. So first step is to identify the U. Second step is to take the derivative of U. So the derivative of X squared plus 3 is just 2X, and then we got a dx. And so now let's see what we got. We have that taken care of. And then what else do we have left? We have this X and we have a dx. Well, we have an X and a dx here. So let's divide this one by 2. So we get du over 2 equals x dx. And so now we got that. We got the little squiggly line for the x and the dx. So we have everything covered, and that's what you want. You want everything in the function to be accounted for in the u and the du, except with the exception of a constant. Like if we had a 2 out here, well, if we had a 2 out here, that would actually help. But if you had let's say a plus 9 out here, you don't really have to worry about the plus 9. So you don't have to account for absolutely everything, but everything involving an x. So this 3, we need to make sure that it's accounted for because it's under the square root. Um, Everything you really need to kind of account for in the u and the du. So we got u equals x squared plus 3. We have du over 2 equals x dx. And so now we can make this substitution. Square root of x squared plus 3 becomes the square root of u. And then we have du over 2 is going to replace the x dx. So we'll put this like this for now. Um, and so let's rewrite this and then we'll integrate. So let's pull the 1/2 out, and you could pull it out inside the integral if you wanted. And then we'll write this as u to the 1/2 because it's easier to integrate that way. So we have 1/2 u to the 1/2. And now it's just very easy. If you've been paying attention to the last few sections that you've covered, you can do this. So let's take the 1/2. We'll add 1 to the exponent. And then we'll divide by that new exponent, which is 3/2. And then we'll need a plus c out here. And so now let's simplify this. So we have 1/2 divided by 3/2. That is 1/3. U to the 3/2 plus c. Now we need to substitute back. So the u is x squared plus 3. So let's put that back in. 1/3 x squared plus 3, 3/2 plus c. And then that should be our answer. Now you can pretty easily check these, make sure that it's right. So if we take the derivative of this, we should end up with that. So let's try that. So let's do 1/3 x squared plus 3 to the 3/2 prime. So this is just very easy. Chain rule, 3/2 times 1/3, that gives 1/2. Then x squared plus 3, subtract 1 from the exponent, that gives 1/2. And then now multiplied by the derivative of x squared plus 3, so that would be times the 2x. So now we have 1/2 square root x squared plus 3 times 2x, and that just the 2 and the 1/2 cancel out. We have x square root x squared plus 3. So that checks out. So when you're doing these, you don't always have to know immediately what your u is. You can try something and see if it works. Um, and in fact, I think it would still work even if you just let u equal x squared. I think that would still work. Um, so try a u, like try something for a u, take the derivative, and then you want to make sure that all your x's are accounted for in the du and the du, and then make the substitutions, see if you can integrate at that point. Possibly when you get to calculus 2, you may have to do this twice. That could happen, I guess. Um, but getting that u is the most important part. If you if you try it and it doesn't work, then try a different U. And then, I mean, there aren't that many, usually there aren't that many possibilities to try before you hit the right one. So, if you got any questions, comments, you can leave those. If you have any other problems you want me to do, you can leave those in the comments.